Hello, welcome back to our channel. I am Anisha Mam, faculty for class 12. We have started chapter number 5 of class 12, that is continuity and differentiability, and we have started the solution, like solving the questions of exercises of this question, in which we are doing right now our exercise 5.1. Now in this video we're gonna solve question number 19 and 20 of exercise 5.1. Let's begin. So question number 19 of exercise 5.1. So first of all, always read the question carefully, like make a list what you have to do in that question, then start your question. Then like if you do these things now, then your that will be helpful for you to solve the question. Okay, so our question is, show that the function defined by g of x equals to x minus greatest integer of x. This square x is denote the greatest integer of x less than or equal to x is discontinuous. What we have to show, we have to show that g is discontinuous at all integer points. Okay, so what we are given? We are given with a function that is nothing but g of x is equals to x minus greatest integer of x. Now, as you can see, this is like completely defined for any real. So here our domain is R. There is no issue in that. Then what to do? To do is like we have to show that f is sorry g is discontinuous at any integers. Let's be like so what we have to do, we have to show that the function is discontinuous. So there are only, we know that if the function is discontinuous, so like then there are only two possible ways. First, that your function value and your limit value are not same, first case. And the second case will be when your limit does not exist, right? Or like either your function is not defined. But as you can see, our function is defined, so only possible case that the function value and limit value is not same, and the another case is limit does not exist. So as you can see, first we have to find the limit, then we have to equate with the function, right? Function value. So let's begin starting with like checking the existence of our function. So let's take for any integer, we have to take like any integer, let's say z. Okay, so first what we have, we will find the limit of x tends to z of g of x, right? So now as you can see, so what we will do for finding the limit, what we will do, why we will find by using left hand and the right hand limit. Okay, as you can see, take it as a g. Okay, when you are coming from your left hand side, so then as is an integer and you are coming from the left hand side, so first of all I will write limit of x tends to z minus f of x, sorry g of x. This will be nothing but limit of x tends to z minus of x minus greatest integer of x, right? Now as you can see, we are coming to z from the left hand side, so the greatest integer less than or equals to the numbers from here will be, like we are coming from this part. Okay, so this will be the greatest integer will be z minus 1, right? So this limit will be z, this like limit of x tends to z minus 1, we know that this is z only, so this is z minus 1, so this limit will be nothing but 1. Now let's find its right hand limit. When you are approaching from the right hand side, so your like it is limit of x tends to z positive x minus greatest integer of x. Now what you are doing, you are just coming from the right hand side, and if you are coming from the right hand side, your numbers are like greater than z, so greatest integer less than or equals to that from this numbers are is nothing but z, so this limit value is nothing but z minus of that, that is nothing but 0. Now what you have seen, that the left hand limit and right hand limit are not equal for, they are not equal for any integers. So from here, as the limit does not exist, so from here what you conclude, that limit not exist. If limit not exist, then there is no chance that the function is continuous. So from here what we conclude, that the function g is discontinuous at x as and z, where what we have started, z is any arbitrary integer. So what we get, so for any arbitrary integer, for the function is discontinuous. So we are done. Now if I like give you some extra information that will be helpful for you for like to solve some other questions, but this g function, like this is a special kind of function, this is x minus greatest integer of x. This g is nothing but what we call, this is curly x, that is fractional part of x, that is called fractional part of x. Okay. For example, if I tell you, if you have a number, say 2.1, then g of 2.1 will be 2.1 minus of 2, that is nothing but 0.1. And as you can see, in 2.1, the fractional part is nothing but 0.1. So what you get is this. So now, if like I already explained you in the previous questions, I think in question number 17 and 18 also, whenever you have to check the continuity and differentiability, there is an easy way to make the graph. If you like easily make your graph, then always try with the graph. So so if you know that your g function is nothing but, if you know that your g function is nothing but fractional function, and you can easily make the graph of the fractional function. May I try the next one? So g of x is curly x. It's a fractional function, right? So if you try to make its graph, so for 0, 1, 1 to 2, 2 to 3. So if you can see, so like for 0 point, like for example, half, its fractional part is nothing but half. For 1, the fractional part is 0. So it will take the value like this. At 1, the function value is 0. So the graph will be like this. Its graph will be like this, containing in this manner. Containing in this manner. Okay, so what you have seen, you have to lift your pen at every integer, at any integer or at every integer. If I try to like say in more proper way, so you have to lift your pen at any integer. That means the function is discontinuous at any integer. So the function is discontinuous at integer numbers. So we are done with this question. Now let's move to the next question. Okay, so our next question is this. Here, what we have a function f of x is defined like this, and we have to check in this question. This is question number 20 of exercise 5.1. We in this question we have our f of x is defined like this, and we have to find the continuity of the function. We have to check whether the function is continuous at x equals to 0 or not. So we know that, like, I think I can give you it as a homework, but let me do it for you because maybe I think I can add some things more, so it will be helpful for you. So it's a easy question. It's not that much hard. So first, for function value, for like to check the function is continuous or not, what we need function value. We need, that means f of pi. As you can see, this will be pi square. Sine of pi is nothing but 0. That is pi square plus 5. So this is our function value. Now let's find the limit value. So in limit value, what you always try to do, that is limit x tends to pi, our f of x, that is nothing but limit x tends to pi x square minus sine x plus 5. Now, if I like give you a way that what you can do is as it's easy to find the limits, right? Because it's just nothing but pi square minus like sine pi, that is nothing but 0 plus pi, that is nothing but our f of pi. I can easily write the limit if you guys know. But if you think that it's hard for you to find the limit like this, I can give you another way. So what you guys can do, change your limit. This, take it as a what you can think, take it as a h tends to 0 and replace your x by pi plus h. See, when your h tends to 0, then your x tends to pi. The same thing is happening. So our limit will become limit of h tends to 0, pi plus h whole square minus sine pi plus h plus 5. So this will be taken as limit of h tends to 0, pi plus h whole raised to 5 minus limit of h tends to 0, sine pi plus h plus 5. Okay, so this, because there is no h in terms here, so this limit will be 5 only. So just what I did is I gave the limit to each and every terms. So this will be, as h tends to 0, this limit will tends to pi square. This is square, right? So this will tends to pi square. Now I can rewrite it as limit h tends to 0, as we know that sine of pi plus h is nothing but minus sine h plus 5. Now what you will get, that is pi square. And we know that as h tends to 0, so sin h will tends to 0, because sine 0 is 0. So this is nothing but 0 plus pi. This is nothing but pi square plus 5 and this is nothing but our f of I. So what we get? The limit value and function value are same, so therefore the function will be continuous. That means what we get. So our conclusion is f is continuous at x equals to 5. I know that it's easy. It's a easy question, but like I am giving you another way. How can you guys use the limits in such a way? If you think that the like taking x tends to pi directly, it's difficult for you. You can change the limits, right? There is no issue in that. So this type of questions may be like helpful for you for a practice. You can like do this type of you should do this questions as in your practice, because it will be more helpful for you. Like how should you guys change your functions? How should you sorry, not functions, how should you guys change your limits in different ways so that you can easily find the limit. It's a very easy like approach to solve the limits also. So although we are doing continuity, but I am just because continuity is like totally dependent on limit also. So that's why you should have a proper concept of limit. I know you guys will do this like you have did your in your 11th the limit chapter also, then you can easily know this. But for my so my like if I want that you guys should know some another different trick, that's why I just gave you something. So that's all for this today's video. We have completed 19 and 20 question of this exercise 5.1. If you guys have any question, please ask me in the comment section. And till then, bye. And please don't forget to like, share, and subscribe this video so you can easily come to this YouTube channel as you want. Thank you.